Do you ever print two things that are supposed to go together and they don't? It happens a lot, so I think it's about time we talked about it. Let's go. This video is sponsored by PCBWay, more on that later. Also, a trigger warning. Words like tolerance, fit and clearance, these are engineering concepts. They are going to be used interchangeably in this video to basically mean all the wrong things. I am not an engineer, and this will become painfully obvious in the next few minutes. So, this thought process started really with Prusa Slicer and the new pegs feature. In case you didn't know, Prusa Slicer now has these automatic pegs that you can make, but the problem is, on the default settings, they almost certainly will not fit. The reason why is pretty straightforward. FDM is a process of pushing plastic, nice alliteration there, through a round nozzle into what's often called a bead, and it's somewhat predictable, but it's not square. At least not at the edges. You are effectively guessing where the edge of the filament will land based on the shape it makes and how far it expands outwards as it's laid down. If you add to that the variance between filaments and viscosities and nozzle sizes, you have exactly the problem we need to solve. Stuff doesn't fit, or stuff fits on the designer's machine, they share the STL, and it doesn't fit on yours, and so on. Before we get onto what I made to try to solve this, I want to just fly by a couple of important concepts. The first is about wall ordering. Cura calls it wall ordering, Prusa Slicer calls it external perimeters first, which is more obvious, but it's completely the same thing. If you imagine the process of extrusion, but larger, the number of walls is typically more than one, unless you're doing weird stuff. I mean, sometimes you use one wall, like vase mode, but the default for a slicer is to draw the center line first, and then move to the outside wall last. But as you probably guessed, the aforementioned setting reverses that and prints the outer walls first and the inner walls last. The issue is, if you print the inside wall first, then this is a whole messy process in real life where the inside wall will squish, it will settle, and it will expand outwards because there's nothing constraining it, and it will cool. And when you have to print the outer wall, it's like when you find a seat in the cinema that you've booked, but the person next to you has already got there before you, and he's sprawled over the armrest, and you have to kind of politely try to lean over to the other side. We've all been there. The way a slicer works is to assume that when you place the nozzle in the center of the line width, which is how it does it in Cura at least, and then extrude, you get equal amounts of material deposited on each side of where the center of the nozzle is. But in reality, due to the guy in the next seat hogging the armrest phenomenon, the second and subsequent lines in a perimeter will not sit perfectly centered like the ideal scenario the slicer will have you believe in the preview. So, because the bead will be constrained on one side, the result, which seems obvious now we think about it, the edge will overfill on the other side. In my experience at least, this gets worse the more walls you have, so the effect will compound. This is why outer wall first exists, to try to direct that squish the other way. I know it sounds like you ought to have outer wall first as a default, and that seems like it ought to make sense, and it is true, but the reason it's not default in slicers is if you try doing outer walls first with any overhangs, then you will soon see the problem with that. So, at least on models without overhangs, until slicers get smarter about wall ordering, and they could change the wall ordering by layer. Until that happens, it's a good idea to set outer wall first on models that you want to be dimensionally accurate, but also make sure that any overhangs are correctly supported. So that is all well and good, but being dimensionally accurate is only half the story. Parts still need to actually fit, and even dimensionally accurate parts won't fit if you don't allow for the real world. If a peg is the same size as the hole it's meant to go into, it seems like common sense that it won't fit. We need to allow a clearance between parts. Even theoretically you need to do this. You can't have two sets of edges of two objects occupying the same space. But how much tolerance you need to allow in your design is pretty much guesswork and highly subjective. I'll show you what I did after the sponsor segment, which is of course for PCBWay. And I certainly imagine their PCB tolerance is a lot better than you can get on an FDM printer. That gives me an idea actually. PCBWay can make parts using methods you can't if you have an FDM printer. So if you want or need tolerances far more consistent than you can achieve at home, then you could consider, say, DLP without having to deal with resin at home. You could choose the service for 3D printing, send your STL file, just upload it, and PCBWay will take care of everything. There's also CNC machining, sheet metal processing, injection molding, and of course PCB manufacturer. And there's extensive guides on each of those if you click on the respective services. So even if you aren't familiar with a service, you can get the information you need to design appropriately for that service. Go check out PCBWay's website at the link below in the description, and thank you PCBWay for sponsoring this episode. So back to the video. I made this. Some of the stuff I make is useless, some of it people find useful. I think it's quite early to call it on this one, but even if it's totally useless, then at least hopefully we've learned something here, and you leave with some knowledge about wall ordering, linear advance, clearances. We'll get to linear advance in a minute, but this gauge is for finding the right tolerance for the filament you're using. If you are printing parts on multiple printers with different filaments, and those swell in different amounts, and for example silk filament, it really does swell. If you haven't noticed that, then yeah, you can watch it swell just as it comes out of the nozzle. You may think you have the right spacing between parts, but often you don't, and there is no way to gauge that without having to print the entire part, watch it fail, print it again. This is all a huge waste of filament. Until now, because this gauge hopefully solves that. What we have is a gauge piece that you print on one printer or in one filament, and then some pegs that you print on the other printer or filament. It's imperative, very imperative, that for these two parts you print using the exact same settings and conditions. That means the same filament and printers and speeds that you plan to print with. Otherwise you're not going to get an accurate representation of the actual materials you're using. The pegs have dots on the bottom. This indicates the clearance that has been built into the peg relative to the gauge. So a peg with 2 dots on the bottom has 0.2mm built-in clearance, as in it's built into the design. If you know that your design has 2mm of tolerance, then use the peg with 2 dots. You then want to try to fit that peg into the center hole of the gauge. If it fits perfectly in both the round and square holes in the center, then you are good to go. Your part will hopefully print with the right spacing. But this is also a diagnostic for when inevitably it doesn't fit in the center hole or it doesn't fit properly. You have 2 choices when that happens. You can remain on the same peg, i.e. using the 0.2mm of clearance, and you can move left or right on the gauge until you find a good fit. And this will give you the percent reduction, or maybe even an increase, not very common, that you might think about adding to get a good fit. Finding that the peg fits in the plus 2% hole would mean, for example, you need to make the part 2% bigger for the peg to fit into, or thereabouts. Or if you're designing the part yourself, you might want to control the clearances, in which case you can swap out the pegs until you find one that you like that fits in the center hole, and then you know the clearance that you want to design for. Of course, bear in mind that there are different desired fits. You might want an interference fit, which uses friction to hold parts together, and those I think are probably the hardest to pull off in FDM because everything has to be absolutely perfect. Or you might just want different levels of clearance. It's all down to the intended use. If you don't know the designed clearances on the part you're printing, then remember that slicers have tools in them that allow you to measure distances between parts, and you can use this to figure it out. You have the new Prusa Slicer measuring tool, for example, and there's a plugin in Cura for it too. I think this is quite a cool idea, but I have literally only just made it, so I really have no idea how well it works in the real world, or whether I just haven't thought it out properly. It might be absolutely useless, so I hope you will consider trying it out and giving me some feedback. I will link to it below in the description. I think there's probably a need for a larger one for larger line widths, because on a 0.6 nozzle you probably need bigger pegs and bigger holes. I just didn't want to waste any more filament than necessary, so I will follow up with a larger gauge for that use. So finally, what about the situation where the round peg fits but the square one doesn't? This is kind of inherent to how FDM printing works, so it will not be a surprise if that happens. It's actually pretty common. FDM does not make perfect squares. In fact, it doesn't make perfect corners. It's actually far better at circles. And this is something that Linear Advance actually addresses. So if you find this is a huge problem where the corners are particularly expanded out compared to the sides, making squares look a bit like cushion shapes, then this is almost certainly something from poor pressure control, and if you have Linear Advance available on your printer, then that's where you need to start looking first. But even that aside, I think it's inevitable that parts with straight edges and corners, like squares, will need more tolerance than round parts. meaning round pegs will always fit square holes. So I guess we know why that saying is the other way round now. Of course, this is an ongoing discussion. I'm interested to see where this goes. As usual, please comment below and let me know what you think, any feedback and so on. Remember to subscribe if you're into this kind of thing, and I will see you next time. Thank you for watching.